Hi, geometry classes. We're working on lesson 11.6. We're going to go over the guided practice for this lesson where we are finding volumes of prisms and cylinders. So we're going to start with three theorems. Theorem 11.6 talks about how to find the volume of a prism. Remember, a prism is a solid figure that captures all the space between two bases that have exactly the same area. So for our first theorem, the volume will be equal to the base area times the height. So here our base area happens to be a rectangle, so we'd find the area of the rectangle for this base, and we'd multiply it times the height. And it doesn't matter which base area you're talking about, the top or the bottom, because they are congruent, they're exactly the same. Theorem 11.7, the volume of a cylinder, which is another prism as a solid figure. This happens to be a prism that captures all of the space in between the circular bases. So our theorem actually gives us the same exact formula. The volume is base times height, so the area of the base on the top or the bottom times the height. This time, though, the base is going to be the area of a circle. So we're going to replace the base with pi r squared, where r is the radius and h is the height of the cylinder. So to find the volume of this cylinder, we would multiply pi times r squared times h height. Theorem 11.8, Cavalier's principle. So this is a theorem that talks about the relationship between a solid, such as a cylinder, and its volume compared to a cylinder that's kind of been tipped over on its side. Would it have the same volume or not? And the answer is yes, it would. So both of these cylinders would have the same volume as long as the height of the cylinder is exactly the same as the distance between these two bases, which would also be called the height. So it's the perpendicular distance to the base. And then as long as their radius is the same. So as long as both of these figures have the same height and the same radius, their volume would be the same. So if you want to figure out the volume of this tipped cylinder, this oblique cylinder is the mathematical name for it, then you would simply plug into pi r squared h. All right, let's look at some examples to see these theorems in action. Example 2. Letter A, what is the volume of the solid figure that you see here? Well, you see a prism, and the bases of this prism are trapezoids. So we're going to find the area of the trapezoid base, multiply that times the height, the distance between the two bases, and then we will have calculated the volume of this three-dimensional solid figure. Now the base here, when we plug into this volume formula, the base has to be the area of the trapezoid, and recall the area of a trapezoid can be found by multiplying 1/2 times base 1 plus base 2 times the height of the trapezoid. So we call this little h here. Now notice that when I am writing this out in my formula, my base is 1/2 b1 plus b2 times h. And then I multiply times a capital H to distinguish it from the height of the trapezoid. The big H will stand for the distance between the two bases. So whenever you see a big H and a little h, we're going to know the big H is the distance between the bases. And the little h will be the height of the triangle or the trapezoid or whatever two-dimensional figure we're finding the area of. All right, let's plug in all of our numbers. Volume is equal to 1/2 times, well, the bases of this trapezoid are 6, because this is 6, and 14. So this is 14. So no matter which base you look at, the trapezoid on the top or the bottom, their b1 and b2 are 6 and 14. So that's what I plug in here. Their order doesn't matter. Times the height of the trapezoid, which is 3, and we're told that right here. The distance between the two bases on the trapezoid is 3, and times the height of the actual three-dimensional figure, and that's 5. The distance between those two bases is 5. And we simply simplify this. So 14 plus 6 is 20, and then half of 20 is 10, 10 times 3 is 30, 30 times 5 is 150, so our volume of our solid is 150 cubic centimeters or centimeters cubed. So we have found the volume of our prism that happens to have trapezoid bases. All right, what's the volume of the cylinder? Well, we're going to use our formula V is equal to pi r squared h. So they give us the radius 9. Be careful on some of these problems, they'll give you the diameter, and you'll need to cut that in half, divide by 2 to get the radius. We'll always plug in the radius, not the diameter. So they give us that diameter here, 9, and then our height is 6. That is the distance between the two bases. And we'll use our calculator to work all that out. And we will get approximately 1,526.04 feet cubed. And remember, if you're using the pi button on your calculator, if it exists, then your answer will be slightly different than what you see here. I'm always using 3.14 for the value of pi, which is not as accurate as the pi value in a calculator that has a pi button. All right, example 3. Example 3, we're asked not to find the volume of this cube. We're told it's 9 inches cubed. We're asked to figure out what is the length of each one of these edges, which are all x. The cube will have a length, width, and height all the same. That's why these are all labeled x's. Well, let's go back to our formula for the volume of a prism, and that will be volume is base times the height. Well, in this case, our base and our height will be filled in with x times x times x. The base, which is the square on the bottom, is x times x. That's our b, x times x. Length times width is the area of the base on the bottom or the top. And our height is x. And we're told the volume is 90, so 90 is equal to x cubed. And then we're going to take the cube root of both sides, and that's going to give us our x. Now, when you plug into your calculator, what is the cube root of 90? Lots of ways to do it on many of your calculators, but one way that will work on all of them is to plug in 90 to the 1/3 power. Remember, when you raise to the 1/3 power, that would be the same thing as taking the cube root. Some of you might have a cube root button on your calculator. This will be a way, however, that will work on all of your calculators. 90 raised to the 1/3 power. And that's going to give you a decimal with lots of digits. We'll round off to the nearest hundredth, so about 4.48 inches for each of those edges, which are x. All right, example 4. What's the volume of this oblique cylinder? A cylinder that's been tipped on the side. We can use Cavalieri's principle here. And so we're going to say that volume is pi r squared times h, where our height is the distance between the bases, the perpendicular distance between those bases. We're again given the radius. Be careful again, if you're given the diameter, when you're plugging into a formula with radius, make sure you cut that diameter in half first. Volume then is pi times our radius squared, 4 squared, times our height between the bases, 7. I'll go ahead and do some simplifying first. 4 squared is 16. 16 times 7 is 112. Then I'll use my calculator. Pi times 112 is approximately 351.68 centimeters cubed. All right, our last volume problem before we start our homework is finding the volume of this oblique triangular prism. So we will use Cavalieri's principle again that says that the volume of this oblique triangular prism will be the same as a triangular prism that's a right triangular prism. The height will be the distance between the bases. So 1/2 times b times little h will give us the area of the triangle. That's the base. And then we'll use the big H for the distance between the bases here in our three-dimensional figure. So plugging in, volume is 1/2 times 9 times 5. Those are the bases of the triangle. Our little h will be the height of the triangle. And then our big H, which is 8, the space between the bases. And then we will simplify that. 1/2 times 8 is 4. 9 times 5 times 4 simplifies to 9 times 5 is 45. 45 times 4 is 180. So 180 meters cubed will be the volume of this oblique triangular prism. All right, that's all of our guided practice. It's time to move on to your homework problems, and we'll see you next time.